Great song for you today. Classic. One of the greats. I'm telling you, if you haven't heard it, go listen to it today. Alright? Seriously. I wish I could get to the chorus, but we just don't have enough time for that. This reminds me of high school. High school. Getting our first car. Not that I had a car, but one of my friends had a car. Little man. All right. Here we go. Let's talk about today and next week. Next week, remember, we have our assessment next Thursday. Today, we're just going to review division of polynomials. I know I kind of glossed over that a little bit on the previous lesson, but I wanted to give you another lesson on finding zeros and everything. All right, so a little bit more practice for you. Today, our goals for today, obviously, is to be able to use polynomial division. A couple things I want to talk about before we do that. Polynomial, like what it looks like. Okay. An example of a polynomial could be something like this. All right. That's an example of a polynomial. Factored form of a polynomial, if you're ever asked for that, that's something like this. Okay. Zeros, if I ask you for zeros, I'm looking for x equals 4, x equals -2, x equals 1. Okay. X-intercepts, if I use these zeros, I would write them as 4, 0, -2, 0, and 1, 0. Okay. So make sure you understand the difference between the three. All right, if I ask for a polynomial, this is what I'm looking for. If I ask for factored form, I'm looking for the factors. Okay, if I ask for the zeros, x equals number, and x-intercepts are just written as ordered pairs. Okay. First one, we want to divide. Divide x minus 2. Divide this by x minus 2, so that tells me that 0 is x equals 2. How did I get that? By setting that factor equal to 0. And so I'm going to put 2 in the box. I'm going to have 1, -5, 6. 1 comes straight down. 1 times 2 is 2. Add straight down to get -3, to get -6, to get 0. And that's how you know you won. Okay? So the result would be x minus 3. Remember, my result is always 1 less than the degree of my beginning polynomial. My starting polynomial was x squared, so the result was just x to the first power. Excuse me. Why don't you pause this one? All right, pause here. I want you to try this one yourself. Go for it. All right, here was my work. Okay, I got x minus 6, remainder 9. Now, obviously, this was not a 0. That's okay. You can get a number here. That just tells you that when this is a 0, that this number here is a 0. Since this is a 9, I can actually write this as -2, 9. Okay? That's what this is. The ordered pair is -2, 9. If I plug -2 in, I get 9. Same idea here. This ordered pair is 2, 0. That's what our result is. Okay? The result of synthetic division gives you the y. This is your input. This is my output. Okay, input, output. We've talked about that a lot. All right, so use polynomial division to accurately graph the polynomial below given x minus 4 is a factor. Well, if x minus 4 is a factor, then x equals 4. Okay, what am I going to do? I'm going to plug 4 into the box here. I'm going to have 1, -4, -4, 16 across the top. Draw my line. Draw the 1 straight down. 1. 1 times 4 is 4. -4 plus 4 is 0. 0 times 4 is 0. -4, -16, 0. Okay. That tells me already that 4 is a 0. Excuse me. This is a 0 of my function. Okay. I also know that, all right, well, I started with x cubed. That means that this is x squared plus 0x minus 4. Or what we're used to is x squared minus 4. Now, if I want the completely factored form, I'm going to have to factor this. Well, this is the difference of two perfect squares here. If it's x squared minus 4, then it's x plus 2, x minus 2. So completely factored form, f of x equals x plus 2, x minus 2, and x minus 4 from the beginning. All right, that x minus 4, remember, came from here. Now, if I have x minus 4 as a factor, that means x equals 4. If I have x plus 2 and x minus 2, that means I have x equals 2 and x equals negative 2. Okay, I want to draw a quick sketch of my graph. All right, well, if I know that this number, I know that the number on the end right here, this number here is my y-intercept. Why? Because if I set x equal to 0, this is the only number that will remain. So technically, if I were to graph this, my graph will go all the way up here. Now, this is a cubic, all right? It's an x to the third, okay? Not only that, it is positive, all right, which means I'm going to go down and up, all right? The shape of our graph, since it's a disco man, whoops, that's terrible, is going to look something like that. In an ideal world, it'll go exactly through 2, but I just made my dot bigger there. Now, how far down you go doesn't matter. Okay, that's not important. All right. How far up you go doesn't always matter, but you want to try to hit the y-intercept if you can. Okay, this is a good sketch. It's gonna, it's a sketch. It's just a sketch. The most important parts of the sketch are these 3 points, are the 4 points in red. Those are the most important part of the sketch. And this part here. Okay, because if it was negative, it would be flipped. All right, let's see if I have a negative one here. I do not. All right, well, anyway, just trust me. I won't necessarily ask you to sketch this, just given a function. All right, that'd be pretty tough given these days. Here we go. So if I have x plus 4, that means x equals negative 4, right? So I put negative 4 in the box here, okay? That means I have a 1, a negative 2, a negative 19, and a 20. 1 comes straight down, 1. Negative 4 times 1, negative 4. Negative 6, negative 20, positive 24. 5, negative 20, 0, we win. So now I have x squared minus 6x plus 5. Well, I want 2 factors of 5. 5 and 1 are the only 2 factors, so it's going to be x minus 5 and x minus 1. Okay. If I have x equals negative 4, all right, my completely factored form, f of x equals x minus 5, x minus 1, and x plus 4. My intercepts are 5, 1, and negative 4. My y-intercept is again off the graph. So it's going to look again something like that. All right, obviously this looks a little funky. That's okay. It may look funky. That may mean that this one goes all the way down deep. That could happen. All right, but I won't ask you to do that for sure. Okay, that's a little review of this stuff. Given the polynomial, find the zeros. All right. For your practice today, okay, I just want you to do the synthetic division portion, okay, and find your zeros that way. You won't have to sketch a graph. All right. Let me know if you have any questions.